So the last piece of the puzzle, and then we'll pretty much be done with sequential streams, is to talk about how to implement custom non-concurrent collectors. And so here we're going to see how these can be implemented the way we want to implement them if what we get out of the box is not sufficient for our purposes. And we're going to take a look at a couple of different implementations of non-concurrent collectors from the SimpleSearchStream program that we've been looking at as a running example through a lot of the sequential streams discussions. So the first example is going to focus on the toString method in the search results class. And this uses Collector.of to format the results. So if you can see here, we want to be able to print out that the words like Ray and La and T and me and so on, where they matched, at what index locations in the Do, Re, Mi song lyrics. So this is a custom collector that's going to format the output the way we want it to be done. So the first thing we're going to do, notice how we say mlist. Mlist is the list of indices, .stream, so now we have a stream of result objects. And then we just say collect. So we go directly from stream to collect. Do not pass go, do not collect $200, just go there directly. And we're going to use the of method, which is that 5-parameter version of. Now, you might go, well, gee, there's only 4 method parameters passed here. That's because characteristics is optional. So we're just going to leave it be the default. So Collector.of, we're going to give it the supplier. In this case, the supplier is going to be a factory method that creates a new StringJoiner. A StringJoiner is a utility class or a helper class in Java that's used to join strings together by indicating what should go between the strings whenever they're joined. And we're going to put the vertical bar, just as you can see here, where we have vertical bars separating the indices in the various word match locations. So we make a new instance of StringJoiner. Then we have the accumulator, which takes a joiner and a result. And you can see we say joiner, that's the J, dot add, and then R is the result, and we say toString. So go ahead and take the result and turn that into a string. So like 131, 141, 151, 202, and so on. That's going to be added with the vertical bar because it's a StringJoiner. So that is how we're going to create that particular accumulator. That's the type. Then we're going to have the combiner. Now, we're not using a parallel stream, but we need to put this in here syntactically anyway. And so we're simply going to merge 2 StringJoiners together. So they'll be put together in a way that would most likely preserve in counter order. And then the final thing we do is we provide a finisher. And the finisher takes the internal accumulator, which is a StringJoiner, and it goes ahead and it converts the StringJoiner into a string. So we now have a string that comes back here, and that's what's returned from toString, as you can see up there. And again, there's only 4 parameters because characteristics ... is optional, so we don't actually have to provide it. So that's one way to implement a non-concurrent collector using of. If you have simple types, simple ways of being able to do the either method references or lambda expressions that are passed in here, this is the way to go. Let's take a look at another way to implement a non-concurrent collector. And this particular approach is going to be the implementation of the toDownstreamCollector. And so toDownstreamCollector, if you recall, that was something that we had used earlier when we talked about the SimpleSearchStream. And we used this to combine together a bunch of elements that are going to be used to create a search results object. And we're going to end up taking as a parameter the result list. It's going to merge result lists together. So the type is a search results type. That's what T is. The accumulator is a list of search results result objects. And what comes back from this is a list of search results result objects, but they've been merged together. So let's take a look and see how this is going to work. Once again, we use Collector.of. This time we're using the 4-parameter version, but because characteristics is optional, we only have 3 parameters. We're going to give an ArrayList as the supplier. So it says make a new mutable result container, which is a list, which is an ArrayList. We're then going to define the accumulator. This is really interesting. So what we're going to do is we're going to take the results list and a search result object, and we're going to add all the elements in that search result, because we're going to get a list of the results. We're going to add that to the results list. So the results list is accumulating all of these things. So we're basically accumulating a big list, and we're just adding the results here to the end of the results list, kind of the accumulator. And then the final parameter, which is the combiner, is going to be a little helper utility, which I wrote, called concat in my StreamUtils utility class. And the reason we have this, again, is for some bizarre reason, there's no way in Java out of the box to be able to take two lists and then concatenate them and return it in one fell swoop. And I didn't feel like writing a lambda expression here, so I defined a method, and then I passed it in as a method reference. Here's what concat does. It takes two lists, parameterized by type t, and it adds the second list to the first list to preserve in counter order. Why not? And then we return the first list. It would be nice if that was added to Java. I don't know why they never did it, but at this point it's probably unlikely they'll do it. But anyway, that's the way you can do that in order to be able to make a very simple method reference you can pass as the final parameter. Once again, there's only 3 parameters that are passed here because characteristics is an optional parameter. Now, if you have more complicated custom collectors that, again, don't fit nicely into this sort of method reference or simple lambda expression style, then what you really want to do is you want to inherit or implement the collector interface and then define those methods in an actual class. And we're not going to look at that right now. We're going to wait till we get to completable futures, and we're going to talk about how to do that. And it's really cool, but we don't need to go to that level of complexity. What we've done so far works perfectly fine using the collectors of factory method family, the 2 methods we looked at before. If you want to learn more about how to implement custom collectors, take a look at this video from my friend and colleague, Angelica Longer. And she talks about some really cool things to add as far as accumulators that have much more complexity, and collectors, combiners, finishers, and so on that do much more interesting things. So take a look at that video. It's a nice way of learning how that stuff works. OK, so that's the end of how to implement our custom non-concurrent collectors, where we had to go above and beyond what comes out of the box with things like toList, toSet, toMap, and so on.